One of the most critical steps in natural language processing is breaking text into smaller units. This process is called tokenization, and the smaller units are known as tokens. The most common type of tokenization is word tokenization, where each word in a sentence becomes a token. But tokens don't have to be words. Depending on your use case, they could also be sentences, subwords, or even single characters. We use tokenization because breaking text into smaller parts makes it easier to analyze and understand. For example, looking at individual words can reveal patterns, like which words are most common or how often specific terms appear together. Now let's look at some examples of sentence and word tokenization using the NLTK package. First, we import the package and download punct tab. This is the punctuation table used to figure out where sentences begin and end. Then, from NLTK's tokenize module, we import two functions: word tokenize for splitting text into words and sent tokenize for splitting text into sentences. Okay, now let's create a string that contains two sentences. Her cat's name is Luna, and her dog's name is Max. We then use the sentTokenize function and place the sentences variable inside the parentheses to split this string into individual sentences. Let's execute. The output shows the text broken into two parts. The first sentence is "Her cat's name is Luna," and the second is "Her dog's name is Max." Next, let's try word tokenization. Take the sentence "Her cat's name is Luna" and store it in a new variable. Then run the word tokenize function on it. Yes, the sentence is split into individual tokens, where each word becomes its own token. Now let's try this on a slightly longer text. We join the two sentences together. When we run the word tokenize function on this combined text, it breaks everything into tokens again. This time, we see all the individual words from both sentences listed out as separate tokens. Notice the difference in casing in the tokenized output. The first token is her with a capital H, while later tokens include her with a lowercase h. If we had converted all tokens to lowercase before processing, these would have matched. In frequency analysis or other text operations, capitalized and lowercase versions of the same word might be treated as separate entries. That's why, by converting everything to lowercase first, we can ensure consistency and get a much more accurate picture of our data.